what I thought, what people struggle with the most when you're solving these is trying to get rid of the fractions. So knowing what to multiply by, when to multiply, like looking for things that might make it easier, that's what most people want to know. Once they get rid of the fractions, it's usually okay. So what I thought I'd do, and I have tons of examples here, is just to help you get the setup part and talk about, well, why did I set it up this way? Why was this the technique that I used versus this technique? And then move on to another problem. So I'm not going to solve every single one of these. You saw how long that took. But that way you at least see a wide variety of ways you can solve and a wide variety of what these equations could look like, so you can learn tips and tricks for all of them. So that's what I'm going to be doing here. I have tons of examples. I basically looked at this section and took every even problem because I thought that's a wide variety. So let's say we have this. We have 7 over 15w minus 3 over 10 minus 2 equals 0. So I'm going to actually just kind of write down my thinking process here of why, what I would do and why. So because one side is equal to 0, I'm going to write this down. One side is equal to 0. Anything we multiply that side by is still going to stay 0. So it's, you know, if 0 times anything is going to be 0. So in this problem, what I would do is just immediately multiply by the LCD in the very beginning. You don't have to worry about the right side. It's just going to be 0. You're not going to have any really nasty things. So because one side is equal to 0, the best technique is to immediately multiply both sides by the common denominator. So our least common denominator here. So we're looking at our denominators, which I'll highlight here. We have 15w and 10. We don't care about the 2. We're just caring about the denominators. So if we look at the numbers 15 and 10, we want a number that they both have and they both can multiply to, or they both divide into. So it has to be bigger or equal to both of them. So 30, I can divide 15 into 30 and 10 into 30. So my least common denominator is going to involve 30. And then because one of the fractions has a w, the other one doesn't, I need to have a w. So my least common denominator is going to be 30w. So basically you multiply everything by that denominator. And I'm going to try to color code here. So I have 17 over 15w. And then you're going to multiply everything. And when you do this method, you only multiply the tops. We're not going to actually build a common denominator. We're just going to multiply the tops by the common denominator. And we can do this because we're multiplying by the same thing on both sides. So that's why we're allowed to do this. As long as you do the same thing on both sides, you don't have to do the top and the bottom of the fractions. And that equals 0, which then we just multiply by 30w. So I'm just writing that in. Some people, one way to do it is to do this. And then you're basically distributing. But a lot of people, when they write it that way, they tend to multiply the top and the bottom, and then they can possibly make mistakes. So that's why I'm writing it out the way that I did. So if you do it this way, you can start canceling things out. So like here on the 7 over 15w, my w's cancel. And I can do 30 divided by 15, which leaves me with a 2. So this would be 7 times 2, so I end up with a 14. I don't have a w that cancels, but 30 divided by 10 leaves me a 3. So 3 times 3w, that's going to be 9w. Oops. And then I have 2 times 30w. 2 times 30 is 60, so I minus 60w. And then 0 times anything is 0. So you can see that actually, by doing that, because one side was equal to 0, basically the right side is very simple. It was pretty simple to multiply each of these by the common denominator, which is pretty simple to find. And we don't end up with any quadratics, so this is just a linear to solve. So this is actually pretty easy to solve. So I'm not going to actually do the solving, because here I want to show you guys how you get the common denominator and practice that stuff. Once you get to the linear, that goes back to things that we've done. And then if you're wondering what numbers we need to make sure that we don't have, we have a denominator 15w. That's the only thing with a variable. So 15w is not allowed to be 0. And if you divide both sides by 15, that tells us w, 0 divided by 15 is still 0. So whatever you solve for, 0 can't be w. If you get 0 as your answer, then you get no solution. Otherwise, you get whatever number you get. So that's a good technique here. Okay, so this one, 2 over 3x plus 1/4 equals 11 over 6x minus 1/3. So here I've got pretty simple fractions, pretty simple denominators on both sides. So this one I would probably try to do a proportion method, because they're pretty easy to get a common denominator on the left and a common denominator on the right, and then cross multiply. So because the denominators are simple, I'd get a common denominator on the left and a common denominator on the right. So I could do technique number 1. The proportion method. So the common denominators would be, at the left it would be 12x, and the right it would be 6x. So those are pretty simple. It wouldn't take very long, and then you can add them and do your cross multiplying. This one here, because I have an x plus 3 and an x plus 3, I already have some things with common denominators. I would do this like our first example where we did, where I'd put everything with x plus 3 on one side and then cross multiply. So because we have things with common denominators, I'd put them on the same side. Combine, then do the proportion method, which is that technique 1. So we've already done an example basically like that. So as soon as I see things that have the same denominator already, that's the easiest thing to do. It's not as many steps. And here we'd have a whole number minus 2 by itself, so it actually would come out really nicely. get my thing. Okay. So here's one that's a little different. We have 3 over 5 plus 7 over p plus 2 equals 2. So we only have fractions on one side, and the denominators are quite different, but I would still, in this case, just get a common denominator on the left and use the proportion method, because all I have to do is multiply the left one fraction by p plus 2 and the right fraction by 5. So you're only multiplying by one thing. You're basically just multiplying by the other denominator, and then you can combine them and cross multiply. So I would also use the proportion method here. So because we only have fractions on the left, and the common denominator is simple to get. Use the proportion method. So basically, whenever possible, I try to use the proportion method because it's just faster. Okay, here we have 25 over y minus 25 over y minus 2 equals 2 over y. So if you had to guess, what method would we use here and why?
Honestly, I think this is Kyle. I think I know what I would do, but I don't know the exact terms or the.
What would you do?
Reason.
Just go ahead and describe it.
I think what I would do is just end up making the denominator like term the y minus 2.
Mm-hmm. Okay. So actually, that is a good thing that you brought that up. So you're inclined to make this y minus 2. We cannot do that. So because we can only multiply, we can't just add or subtract things to a denominator. So we can't just subtract 2 and get a denominator y minus 2. We can our only rules that we can do are multiplying and dividing for common denominators. So while that sounds like, oh, that's nice and easy, I'll just subtract 2 from everything, that's not going to work. So when I look at this, I notice these denominators are the same. So whenever I see something that has, whenever I see denominators that match, I want them to be on the same side. So I would be inclined to subtract the 25 over y to move it to the right, and then I have a fraction equals a fraction because I can combine those on the right for a like term. And then that's, again, now I have a proportion, I can use the proportion method. So as soon as I see that I have denominators that match, that is the first thing that I see in my head, is make sure those are on the same side, so that way you can combine them and then cross multiply. So because we have matching denominators, put them on the same side, combine like terms, which in this case would be, you'd end up doing 2 minus 25, then cross multiply, which is what I'm calling the proportion method, or technique 1. Now here we have 3 over e squared equals 2 plus 1 over w. So for something like this, there are two different ways that I could do it, but I tend to do this one by multiplying by the common denominator. And that is because W as a denominator is almost W squared. All I have to do is multiply it by a W, because those are practically a common denominator. So whenever you see, denominators, like if you see something that has an x and an x squared, or any variable, but if you see denominators that are like that, where you have a single x and then two x squared, or a single w and w squared, those are really easy to do by multiplying everything by the common denominator. So we will multiply everything by the common denominator, which is the higher power term. So in this case, we'd be multiplying everything by w squared. And that would cancel out my w squared in the first fraction. I'd end up with 2w squared. And then when you multiply by w squared, one of the w's cancels. And so what we would end up with is 3 equals 2w squared plus 1w. So basically you're canceling out your denominators and with whatever's remaining. And so it's like a one-step kind of multiplication. It's not too bad. And then you have here quadratic that you can go and solve. So anything that's in that form, where it doesn't matter where the denominators are located, whether they're on the same side or opposite sides, but if those are your denominators where they kind of start counting up or counting down in exponents, those are the type where you want to multiply everything by that common denominator, which will be the higher power. So here I have 1 over 3t minus 12t to the negative 1 equals 0. So if you see anything that has negative exponents, rewrite them. T to the negative 1 is 1 over t. So you take the reciprocal and then that exponent is 1. So you'd really be looking at 1 over 3t, so you can put that t on the top, minus 12 over t equals 0. So if you have negative exponents, you want to flip them to their positive form, so that way they will all basically cancel out. So once you do that, something like this, it's easy enough to multiply both sides by the common denominator. It would just be 3t, especially with the 0. So this goes back to, I had that other example where it was equal to 0. Let me see if I can find it. I have to go back. This one, whoops, too far. This one where you had one side equal to 0, so you want to just multiply both sides by the common denominator. Just the same advice. Oops, here. One side is equal to 0, so multiply both sides by the common denominator. It will be quicker. Because one side equal to 0, multiply both the sides by the common denominator. So here, this one, now we're starting to get into the more complicated sort of things. So we have a negative 8 over t squared minus 6t plus t over t minus 6 equals 1 over t. So in order to decide what method to use, you want to factor your denominator whenever possible. And the only thing we can factor is this one right here. So we want to factor this denominator so that we know what we're looking at. So I'd have negative 8 over t. I can factor a t out of there. And that leaves me with t minus 6 plus t over t minus 6, and then 1 over t. So when I look at my denominators here, I have a t, which is present in 2 of the equations here. So one of them has a t with something else. One of them just has a t in the denominator. The other one has a t minus 6, which is in the other fraction, t minus 6. So I have one fraction that has both, and then 2 fractions that have one or the other. So when there's a situation like this, I would build everything to have a common denominator because I only have to then multiply 2 equations in order to get it. So build each equation, or I shouldn't say equation, each fraction to the common denominator. Then cancel out all the denominators, basically. Because we'll be multiplying by the LCD. So to demonstrate on this particular problem, the fraction t over t minus 6 doesn't have the yellow t. So I need to multiply that fraction by that t. The fraction 1 over t doesn't have the green t minus 6, so I need to multiply that by the t minus 6. So that way each fraction has a t times a t minus 6. So I'm going to rewrite this. Negative 8 over t times t minus 6 plus t times t is t squared over t times t minus 6. And then I have 1 times t minus 6, so that's just t minus 6 over t times t minus 6. You do not want to reduce because our whole point is to get rid of the fraction. So now we're going to multiply everything by the common denominator. And that cancels out all of the denominators because they all have that denominator. So it just cancels all of those out. And so you're left with just the tops of the fractions. So that's why so basically when you do this, they all have the same denominator, you could ignore the denominators and you're left with just the tops. And so that gives you then something that you can go on and solve. So I only had to multiply 2 fractions by something so that they matched. And then I could just cancel or just wipe out the denominator altogether. So if you have things that are almost the same, that is the technique that you want to do. So if they're almost the same, this is the fastest way to get to the part without the fractions. So here I have x over x plus 6 equals 72 over x squared minus 36 and then plus 4. So again, if you have anything that you can factor, you want to try to factor that out, or to just factor. So this will give us x over x plus 6 equals 72. Now x squared minus 36, this is a difference of two squares. So this factors to x minus 6 times x plus 6. And then I have plus 4. So looking at what I have, these both have an x plus 6, but I don't have an x minus 6. So what I would do is I would build the fractions to have the common denominator, x minus 6. So I'd have to multiply by the x minus 6 so that they match. Now I have things with the same denominator, and then I just have this plus 4, so I can subtract the 72 over the x minus 6 times x plus 6 thing so that I have a fraction equals a number, and I can do the proportion method. So I would build a common denominator. Then we have something that's good for the proportion method. And anything that's good for the proportion method we're going to just try as if you have, in general, you have fractions that match in the denominator, and then they have either another fraction that doesn't match added on, or a whole number added on. Those are the ones that are good to use the proportion method on, to put them on the same side and then cross multiply. So this is very similar to, if I go back enough slides, this one right here, we have the things they match, and then it was another fraction involved, so that's good for the proportion method. This one, same thing, and the ordering is slightly different, but you have the fractions have the same denominator, and then there's a whole number, but that's good for the proportion method. And then this goes back to our first example. Go back far enough. So again, same sort of thing. We had two fractions with the same denominator, and then in this case there was a third fraction involved, but they all had the same form, where you have things with the same denominator on opposite sides, and then you either have another fraction added on or a whole number added on. Those are the ones that are really good to use this method on. So if you can get things in that method, and then you get that in that form, whether it's on the left or the right, it's added or subtracted, then that tells you, okay, this will be the quickest way to do it. Okay, so gradually getting a little more complicated here. So you can start seeing things with multiple denominators that are looking a little crazy, and you're thinking, this has nothing to do with anything. I've never seen anything like this. Like, what do I do? So you want to factor all of these denominators, and that will help you decide what you need to do. So you want to get really good at your factoring so that you can do these in your head. So this will give us a -3, and this factors to x minus 3, x minus 4. So those multiply to a positive 12, add a -7. Now if I see a minus here, and I'm going to just indicate this in a different color here. If I see a minus, I usually will just put that up with the number there. And so I'd write a plus and then put a -2 there, sort of like we did with the -3. We have x squared plus x. That's going to be x plus 4 times x minus 3. And then x squared minus 16 is a difference of squares, so that's x minus 4, x plus 4. So you factor all the denominators, and this helps you decide what you need to do. So I like to highlight what's in common. I have x minus 3 in two of the fractions. I'm going to use a different color. I have x minus 4, x minus 4. And I have an x plus 4, x plus 4. So I've got like 3 different colors going on here. And when none of them have the same thing, but there's 3 different colors, what I do is build them to have the same common denominator and then cancel out the denominator. So that is the best option here. So build them to have a common denominator. Then cancel out the denominator. So how this would work, the first fraction, I have a yellow and I have a green, but I don't have the blue, the x plus 4. So in order to have them match, I need to have the x plus 4. So I'm going to multiply that. Second fraction has blue and yellow, but not the green. So I need to multiply that one by the green so that it matches. Third fraction has green and blue, but not the yellow. So I need to multiply by the yellow so that it matches. So I have negative 3 times x plus 4 over the complicated fraction plus negative 2 times x minus 4 over the complicated fraction plus 10 times x minus 3 over the complicated fraction. Basically, the fraction, whatever's in the denominator, doesn't matter because it's all going to cancel out. So as long as you make sure that those all match, you can cancel it out and you're left with just what is on top. So I'm going to just, so you're going to have your blue denominator here. You'll have your green portion. And you'll have your yellow portion. So there's going to be a messy looking thing, but then you multiply both sides by that denominator, it all cancels. You're left with only the tops. So this is basically what we did here. We built them so that their denominators matched. And then because they all matched, it basically all canceled out. So that way we're left with just the tops of the fractions. So I can continue the color coding here. They all have the yellow T. They all have the green T minus 6. So you just multiply both sides by the denominator, it's gone. You're left with just what's on top. So that's what we're going to go, same thing that we do here. So I recommend color coding if possible to help you determine this, so that when you see you have things with lots of that don't quite match, but they're, you know, they almost have everything. This is the technique to use. Okay, here, going back to my highlighter, notice we have common denominator there plus a fraction. That's what we're here. They're on either side of an equal sign, but they have a common denominator plus a fraction, proportion method. So you're going to want to be able to recognize that pattern here. So we have that pattern, so we want to use the proportion method. Oops, that's the highlighter. So use the proportion method because of the form something plus, in this case, fraction, but I'll write it the same way that we did before, where our denominators match and then we have some other fraction involved. Okay, so I've got a wide variety. We're almost done, but I'm showing you all the tips and tricks. So we've got this 4x squared minus 36. So as soon as you see something that has an x squared, that's telling you you want to factor that. The x plus 3, x minus 3, there's nothing to factor there. So I'm going to have 1 over. First thing I'm going to do is actually factor out a 4 because I have a greatest common factor. So that's a 4. That leaves me with x squared minus 9. Now I'm going to factor further 4. And then x squared minus 9 factors to x plus 3, x minus 3. 5 times x plus 3 plus 2 times x minus 3 equal to 0. So I've got an x plus 3, x plus 3. Got an x minus 3 and x minus 3 there. And I also have this 4 that's part of the denominator. So in this case, because one side is equal to 0, so we've had a few like this, a couple where one side is equal to 0. So it's a good technique to multiply everything by the common denominator here. When one side is equal to 0, that's the technique you want to use. So when one side equals 0, multiply by the common denominator. And so you're going to be multiplying everything by, and our common denominator is going to be the 4, the x plus 3, and the x minus 3. So if you color code, you're going to be multiplying everything by the blue 4, everything by the yellow x plus 3, and then everything by the green x minus 3. So I'm just kind of writing those in with colors so you can see, and then things would cancel. So, for example, the blue 4s would cancel, the x plus 3s would cancel, the x minus 3s would be canceling. So you'd be just left with 1 minus. Our yellows would cancel here. So you'd be left with 5. The blue is 4, and then the green is the x minus 3. So I'm just writing it down. I'm just looking at the colors, not even caring about the variables, but using the colors and kind of canceling those out. And then the third fraction, the greens would cancel, leaving you with the 2, the blue, which is 4, and the yellow, which is x plus 3. And then it's equal to 0, because 0 times anything is 0. So that would leave you with this that then you can go and solve. So we've seen a couple with these equal to 0. And that's a good technique, is to multiply everything by the common denominator, cancel things out, and you don't have any fractions left. Okay, so here I have h over 2 minus 2 over h minus 4 equals 4 over 4 minus h. So what I want you to see here is that these are almost the same. They're almost the same, but not quite. So they're in different orders. One has h minus 4, the other has it in the opposite order. So this has a special technique here. So when you have things that are almost the same, factor out -1 from one of them. Oops. Actually, we specifically do it from the one with the number first. So we're going to factor out a -1 from the 4 minus h because that has the number listed first. So what this looks like is you have h over 2, you have 2 over h minus 4, 4, and then when you factor out a -1, you end up with -4 plus h. So it's basically changing the signs, which then you can put them in a different order. And with that -1, I usually put up on top. And if I rearrange the -4 plus h, that's the same as h minus 4. And so now we have a common denominator here. And so we have our same form that we saw before, where you have the fractions of the same denominator plus another fraction. So we're going to use the proportion method. So you can see that we keep going back to the same method here, or we keep, seeing the same sort of things that pop up over and over again. So we're going to use the proportion method. Okay, 2 more. I'm almost done. I appreciate you sticking with me. Okay, so here we have 9 over x squared plus 7x plus 10 equals 5 over x plus 2 minus 3 over x plus 5. So we have a quadratic, so we are going to factor that. So I have 9, and let's see, this factors to x plus 5, x plus 2 equals 5 over x plus 2 minus 3 over x plus 5. So factor, and I'm going to highlight the stuff that matches in the denominators so I can see what I need to do. So my left, I have both a green and a yellow. The other ones on the right are almost the same. So what I would do here is I would make the fractions on the right side have the same denominator, and then everything has the same denominator, we can cancel it out. So build everything to the common denominator. And then cancel it out. So you'd be multiplying the 5 over x plus 2 by x plus 5 on the top and the bottom. And you'd be multiplying the 3 over x plus 5 by x plus 2 on the top and the bottom. So the missing color. And then the denominators will match, and you can just cancel it out. Okay, last one here. We've got lots of quadratics, so we want to factor all of these. So anything here that's a quadratic, you want to factor. So I'm going to have 5 x squared minus 6x plus 8. Let's see, that's going to be an x minus 2, x minus 4. So as I said, you want to be able to get really fast at this factoring. X squared plus 3x minus 10, that's going to be x plus 5, x minus 2. And then 8 over, let's see, x squared plus x minus 20, x plus 5, x minus 4. So I'm going to highlight my things in common, x minus 2, x minus 2. I've got an x minus 4, x minus 4, and then I've got an x plus 5 and an x plus 5. So we had something else that was similar to this one just a few slides ago. I'm going to look for my colors. That one had 3 colors. That wasn't exactly this one. So you can see where we had 3 fractions and they had different combinations of the same 3 factors. So it's the same form. We're going to build them to have a common denominator and then basically wipe it out. So same form. If you color code, you can kind of see the patterns here, that you have combinations of 2 different colors here. Oops, not the highlighter. So you want to build to a common denominator. Then cancel out the fractions. So like the first fraction doesn't have the blue, so you'd be multiplying by x plus 5. The second one doesn't have green, so you'd be multiplying by x minus 4. And then the last one doesn't have yellow, so you'd be multiplying by x minus 2. And then the denominator itself is all wiped out, and then you have something that you can solve for x. So I know that this was super, super, super duper long, but I wanted to focus on the patterns and what you need to do to build these fractions, these common denominators, so that way you know what to do, which technique to use. You can kind of put it in a little bucket, so okay, this one looks like this one looks like this other one, here's what I do. Once you get rid of the fraction from there, it's just a matter of solving either a linear equation or a quadratic. I encourage you guys to try to solve these on your own based off of the suggestions that I've given here. Try to do the color coding so that you can try to match your common denominators here. And if you want to check your answers, see whether you've got them right, or you want to see, okay, am I on the right track? Feel free to email me, and I can take a look at it for you, and you can see, okay, do you understand what's going on? Color coding here is your friend. So thank you guys so much for sticking with me. And I know it's super, super, super long, a lot to cover. Hopefully that you found this helpful. So thank you guys so much, and I will talk to you later.